Here we go, another limiting reagent question. I know, you are thinking, oh, I'm sick of doing this limiting reagent question. Can you please do something else? That is exactly what you are thinking. I can understand your pain. However, though, doing more of these questions, there's a benefit. What is the benefit? It will give you a good, thorough understanding of stoichiometry, which we are going to use quite often in this topic, especially fuel topic where we do a lot of energy calculations. At the same time, with this example, I am going to show you what actually happened in terms of chemistry finding the limiting reagent. In previous question, do you remember I asked you to do a shortcut? I used to call that shortcut method called icebox method, where you are dividing the number of moles of each reactant given by its coefficient, and then you compare those numbers to find the limiting reagent. I mean, I can understand some of you thought, what is the chemistry behind it? There is no thorough understanding behind that method. So with this example, I will show you how we can actually use stoichiometry and find a limiting reagent. Okay, are you ready? All right, let's take an example for a combustion reaction. What is the combustion reaction I'm going to take? Let's say that we are going to take this one. What is that? This is octane, which is a liquid at room temperature reacting with oxygen. Let's say this undergoes full combustion. In this case, what are the products? Now you need to know what the products are. Full combustion. Don't tell me you do not know. Which is carbon dioxide gas and H2O liquid, right? Okay. Now, obviously, this is not a balance. So let's balance it. Okay, I'm going to balance it. 8 goes here. You want me to use a different color? Yeah, let's. Let's use a different color. Where's the eraser? Okay, let's use a different color, right? For balancing. Let's use a different color. Again, pen. Okay. Oh, it takes time, isn't it? I use the same color. Stupid. Waste of time. So, what? Ayyo, this is too. Yeah, all right. What is going on? Okay. So this is. Oh man. I don't know how to use colors, man. Just give me a second. You should have used the pen. That's pen. Sorry about everything. Be patient. Okay, this is 8. Then 9H2O goes here. Then 9 plus 25 over 2. Oh, sir, my teacher hates fraction. My teachers hate fraction. Okay, if you have got a teacher who hates fraction, then multiply everything by 2. All right, C8, H18, liquid. My teacher is allergic to fraction and the what? Decimals. Stupid. Okay, 25 over 2. Gas. Then what? 16. Where's the O2, man? This is CO2. Sorry. 16 CO2, which is gas, and 18 H2O, right? Okay, which is a liquid, right? Okay, now this is the balance chemical equation we are going to use in understanding limiting reagent concept. In order to make a question, what I'm going to do, I'm going to give you this. Look, I'm going to give you 10 moles of octane. So I'm going to say number of moles of octane given is 10, right? 10.0 moles. Is that clear to you? All right. Then I'm going to give you this one. Let's say 60 moles. So the number of moles of oxygen is 60 moles. Now, okay, I'm going to give you a very simple question. I want you to find out what the limiting reactant is or the reagent is. Is that clear? I just want you to find out what the limiting reagent. That's it. That's it. What's the limiting? What is the limiting? So I don't understand what limiting is. Limiting is the reactant that is going to be consumed first. I mean, especially if we don't have these moles in correct ratios, one reactant is going to be consumed first. And the reaction stops. That is why it is called limiting reagent. Is that clear? All right. Now, do you remember when I ask you to find out what the limiting is? I ask you to use a what box? Box method. Do you remember? What is the box method? I ask you to draw a box. Why did I ask you to draw a box? Because whatever the numbers inside this box are not or should not be used in further calculation. We do this method just to find out the limiting reagent, which is a shortcut. I mean, here there is not sort of very thorough understanding going on there. Just a shortcut. But let us do the shortcut first. Then I'll tell you real chemistry, how to use real chemistry to understand what the limiting. Okay, are you ready? Okay. Now, then what did I ask you to do? I asked you to get the number of moles of the octane, which is C8, H18, which is 10.0, and divided by coefficient. What's the coefficient there? 2. Then 5.0 moles, right? Okay, MOL. 5.0 moles. Then I ask you to get the what? Number of moles of oxygen given. Okay, which is what? 60. Divided by coefficient. What's the coefficient? 25. And which is what? Which is 4. Then which one is a smaller number out of those two? 4 is a smaller number. Then our limiting reagent is the oxygen. Then what did I ask you to do? I asked you to put a circle around the limiting reagent. Yeah, that's called the icebox method. We do this method just to find out what the limiting is. After you have found the limiting reagent, what did I ask you to do? Go back to the original number of moles of the limiting. Go back to the original number of moles of limiting. Okay, I should be using a we should be using a different color. Oh, what is going on here? Go back to the original number of moles of limiting, which is 60, and I ask you to use that for further or future calculation. Is that clear? Now, this is the not icebox method, this is the box method. But and some of you asked me at the time I taught you this, so what is actually happening? What do you mean by dividing by the coefficient? What do you mean by that? That doesn't make any sense to me. Then what did I say? I said, okay, I'll teach you later, mañana. All right, now what I'm going to tell you, without using the icebox method, it's a box method. Without using this box method, I'm going to tell you how to find the limiting reagent. Are you ready? Okay. In order to do that, I want to find the calculator. Yes, calculator is there, and I want to delete. No, not the word. I want to erase this stuff. Okay. So I'm erasing the box. The box is going to go away. Okay. Then let's go back to the question. In this the question, you got 10 moles of octane and 60 moles of oxygen. Okay, now this real method takes time. Okay, be patient. Real method takes time. Everything real takes time. Fake ones, shortcuts, easy. Okay, but we need to learn the real method as well. So the people who want to have a thorough understanding get the idea. Are you ready? Okay. Let me clean that up. Okay. All right. Now we got the number of moles. What? 10 and 60. Okay, now we are not going to use any shortcut methods. Okay, what is the longer method? Longer method is this. You assume one of these is limiting, one of these is limiting, and find out the amount of the other needed. What I am trying to say is this. Okay, when you want to in stoichiometry, what do? You have a known, then you find out the unknown amount of the other reactant or the product. Okay, now look. So the first step is, let's assume if octane is the limiting, or we say if octane is the limiting reactant. Okay, if octane is the limiting, let's say if octane is the limiting, if you are going to assume if the octane is limiting, the oxygen should be in excess. Then let's find out how much oxygen we need if the octane or 10 moles of octane is going to be consumed first. So in other words, we are trying to find out number of moles of the oxygen that will be consumed with 10 moles of octane. So in other words, this is our known. Now we need to find out the number of moles of oxygen, which is our unknown. So doing that, we use the UK method. All right. Number of moles of oxygen needed, unknown. Number of moles of what? Octane, C8H18. Okay. What's the ratio? 25/2. Then, okay, I'm going to do it here. Therefore, number of moles of the oxygen needed is going to be equal to 25/2 times the number of moles of what? Do you see me? Do you see me? Number of moles of this. Okay. Now, what's the number of moles of octane? We have 10 because we assume that to be the limiting. Okay. Then that's going to be consumed first. Therefore, 25/2 times 10. Oh, which is what? Which is 125. Oh, we need 125 moles of oxygen if octane is going to be the limiting. Oh, have you got 125? Have we got 125? We haven't got 125. We got only 60. We got only 60. Then oxygen cannot be the excess reagent. Oxygen is the limiting reagent. Our assumption is not right. Then you have to say, since there are only, I won't write everything here. There are only, since number of moles of the oxygen is 60, O2 is the limiting reagent. O2 is the limiting reagent. Is that clear to you? Reagent. O2 is the limiting reagent. All right. Now you might be thinking, so how did you know exactly? Or why did you take octane as the limiting reagent in that assumption? Okay, let's take something else as the assumption and see what's going to happen. All right. Now I'm going to delete this again. Yeah. Okay. I'm going to delete this. Not delete. What is deleting? This is erasing. Ayyo. Okay, look what I'm going to do, right? This is for the people who want to, okay, look what I'm going to do. Here, I'm going to assume if oxygen is the limiting, in other words, you make oxygen your known. You make oxygen your known. Then we find the unknown. So this time our unknown is going to be octane. Because what we are trying to do, we are trying to do this. If oxygen is the limiting, all that 60 moles will be used, and some of the octane should be used as well. In other words, we will need to have octane in excess. That was assumption. We don't. Now we know that because we have already done the previous part. But if you are going to start thinking that if the oxygen is the limiting, you have to do the calculation. Then the other one should be in excess. Then find out how much of the octane that is going to be used, or whether you have that in excess or not. In order to find out whether the octane is going to be in excess or not, you have to find out number of moles of octane that is going to be used with the limiting. Or in other words, octane is going to be our unknown. This is O2. What's the ratio? 2 to 25. Then what do you do next here? What do you do next here? Okay, what do you do next? You find out number of moles of octane, 2/25 times by the number of moles of O2, our limiting. In other words, according to our assumption, it should be the limiting. So then 2/25 times by, what's the oxygen? 60. Oh, look at that! Look at that! We only need 8 moles of octane to go with, is it 8? No, silly, it's not 8. That's wrong. It's not 8. How come it is 8? Where did you come up with this stupid answer? It's not 8. It's not 8. It's not 8. Oh, 120. 120 divided by 25. Man, I cannot even do division now. Okay, let's use a calculator. Sorry, because it's too late. 120 divided by 25. Man, what? 4.8. Oh, you need only 4.8 moles. Now we know we only need 4.8, but how many moles have we got? We got 8. We got more than enough. That is why. That is the excess reagent. Excess reagent. Is that clear? Now this is how you do, or how you find out what the limiting reagent is without using that shortcut box method. Some teachers may not like that method. All right, I think that's all for now. Let's come up with another question maybe tomorrow. See you. Love you for loving chemistry. See you soon. Bye bye.